Hi everyone, Victor here again, and in today's lesson, we're going to be looking at how to control the scheduling of pods in the nodes, apparently into the worker nodes. Like we have discussed in one of our previous lessons, I guess the first chapter, we learned that the scheduler is the service that is responsible for scheduling which worker nodes a pod will be created on. The scheduler looks at the resources on each worker nodes, RAM, CPU, cores, etc., and then schedules the pods in a way that loads will be balanced across all the worker nodes in the cluster, and it does this by default. However, in some cases, you might not want the scheduler to automatically schedule the pods across the nodes in a cluster due to the kind of design you want in your environment. For instance, some nodes may have a higher computing power than the others, and you might want some of the applications that requires high computing be created in those nodes. Hence, you will want to schedule those application pods on those nodes. Another scenario is if you have to leverage on packages or binaries on particular nodes or local storage of some particular nodes that the pods will use, you might consider scheduling the application pods on those particular nodes. And another reason could be that you might want to separate your production pod from the development pod. So there could be a lot of reasons why you would want to control the scheduling of pods on a particular node or particular set of nodes. And scheduling a pod to a node can be done using labels. We already talked about labels and selectors in one of our previous lessons, so this shouldn't be a problem. Labels can be used to schedule pods to a node, and there are basically three ways to schedule pods to a node using labels. One, we can use the node name field. Secondly, we can use the node selector field. And the third one is that we can use affinity and anti-affinity constraints. In this lesson, we'll look at using node name and node selector fields only. We will look at the affinity and the anti-affinity constraints in other lessons. So let's talk about using the node name field. By default, Kubernetes or OpenShift recognizes some standard definitions in the cluster and assigns them as labels. For example, the host name. Kubernetes assigns the host name as a label to your node. Kubernetes also uses some other attributes of the node, for example, CPU architecture, to assign labels to the nodes. To schedule a pod to a node, you can use the node name field in the pod spec section in your YAML manifest file to schedule a pod to that particular node by using the host name of that node just as we have it here. Say worker node 1, worker node 2, and worker node 3 have host names such as WK1, WK2, and WK3. You can schedule a pod to WK1 by using the node name field. Using the node name field to schedule a pod has its own drawbacks because node names are unique, meaning that pods can only be scheduled on just one particular worker node amongst other worker nodes in the cluster. However, the good news is that you can add additional labels or manually assign custom labels to your nodes. For example, if we have worker node 1, worker node 2, and worker node 3, you can assign labels to these worker nodes using the key value pair. Say for worker node 1 and worker node 2, you can assign a label such as WK node equals front end, and you can use the node selector field in the pod section of the YAML manifest file to schedule pods for the nodes that have the label worker node equals front end. This means that pods would not have to be restricted to just one particular node, and if it is just one pod, the scheduler will schedule the pods on any of the node with the label. This method is very common and of course a better approach compared to using the node name field because you can assign more than one label to nodes and maneuver the scheduling of pods across the node as you want. You might also decide not to use the YAML manifest file. You can also use ad hoc to add labels to nodes. And as we go on in this course, we're going to look at how to do both. So having understood this, let's get to action and let's see the step-by-step guide of how to perform the scheduling of pods in Kubernetes or OpenShift cluster. So first, we're going to schedule pods using the node name field. And if you have been following me from the beginning of this course, you would understand that we've been using a single node cluster, which is the CRC node or the OpenShift local. So if I do OC get nodes, you would see that we only have just one node that is running as both the master and the worker node, right? So we're just going to, make use of these. Probably in other lessons when we deploy the production like cluster, we might, run this again, but it's just the same concept. So what we're going to do is to create a pod, right? And we're going to schedule that pod to run on this node, on this node, which is CRC NV blah blah master dash 0. And I already have a YAML manifest file for that. So if I do vi deployment to the YAML, so you can see that this manifest file is going to create a deployment, and the name of the deployment is Nginx app here, and you can see that here under the spec section is where you're going to specify the node name, which is the node name that we have when we did OC get nodes. So if you have, let's say, worker node 1 or worker node 2 or worker node 3, whichever worker node you want your pod to be scheduled on, you're just going to specify that node name here. And of course, we're going to be creating the Nginx container, right? So I'm just going to create this pod. So if I do OC, oh sorry, I'll just say yeah, OC create file deployment to the YAML. So you can see that the deployment has been created. And if I do OC get pods, so the container is creating. So I can just do watch to see when the container has been created. So you can see that the container has been created now. So if I do OC get pods, you can see that the container is running. And if I do OC get deployment, right, the container is running. So if you want to get the node, the worker node that the pod is running on, you can just say OC get pods and use the wide option. So you can see that this container or pod is running on this node, right? So this is how you're going to, if we had like 5 worker nodes or more than one worker node, we would have specified the node. But just like I said, because we're using a single node cluster, we just only have one node that is running as both the worker node and the master node. So this is how you're going to schedule pods using the node name field. So let's look at how to schedule pods using the node selector field. Just clear my screen. So let's delete the first deployment that we created so that we can have a clean environment. So I can just look for this command again. So we're just going to say also delete. Whereas if I do also get deployment, so we don't have any deployment here any longer. So what we're going to do first is to create a custom label like I explained earlier. So we need to create a custom label. So if I do also get nodes, we just have one single node here. But let's say this is called worker node 4 or worker node 5. You would need to create a custom label, or rather label that node that you want to schedule pod on anytime you want to use the node selector field. So to label a node, we can simply use the command also label node, then followed by the name of the node, which is this. Then we can give this node, let's say environment production. So this is the key value pair. So you can see that the node has been labeled, and if I want to confirm that it has the correct environment label set, I can just do OC get nodes hyphen label, then I can say environment. So you can see that this node has this label environment, which is a production. You can also use the command OC get nodes show labels. So it's going to show you the labels you have on every node. This is environment equals production. So I'd labeled this node before as environment equals quality assurance. So you can, you can label a node, you can give a label to a node as many times as you want, depending on how you want to set your environment. So let's give another label to this node. So I can just say OC label node, the name of the node, followed by the label you want to give this node. So I can just say environ or environment equals to development. So this has been labeled. So if I want to, get the correct environment label cell set for environment, I can just say OC get nodes. Can say environment. OC get nodes. So you can see that it has this node as the label environment, which is dev. So we have like 3 labels on this node. So the next thing we're going to do is to edit the YAML manifest file. So I can just say deployment to.yml. So under the same spec section here, we're going to say node selector. So here we can have environment, which is production. So I can save this. So now I can create the deployment. So if I do OC create file deployment to the YAML, so you can see that this has been created. And if I do OC get pods, the container is still creating. So if I just do OC get pods, I think 0 wide, of course, so let me try and enlarge this, run the command again. So it's running already, and of course it's going to be scheduled on this same node, because like we have said that we're using just one single node for both the master and the worker node. So this is just the concept. This is how to use the node selector field to schedule pods on nodes. And in other lessons, we're also going to look at, the using affinity and anti-affinity. But before we round off with this lesson, let's quickly perform some activities. So let me just run the command again, oc get nodes show labels. So what we want to do is to remove these labels from this node, and to do that you can just use the command oc label node, the name of the node, which is this. Then I can say the key. So let's do for environment first, and I can put dash in front. So you can see that it's been unlabeled with the environment equals production. If I run this command again, oc show labels. So we can't find that label here any longer. And also let's do for that of environ, and we can also do for that of environment. So if I say show labels, so you can see that we have unlabeled this particular node. I'm going to try and create that pod again. So I'm just going to say oc create file deployment to the YAML, and if I do oc get pods, so you can see that this is pending, and that's because don't forget that we have specified a label in this YAML manifest file. So if I do deployment to the YAML, you can see that our label is a node. We're using node selector, and which is environment production, and because you can't, OpenShift cannot find that label on any particular pod, and that's why it would always tell you that this will not be created and the status will always be in pending mode. If I do oc describe pod, if I try to check this, and if you look at the event, you would see morning blah 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 didn't match pod's node affinity selector, and that's why this pod cannot be created except we try to label this node again. So if I try to label this node again, so I can just say oc label node, and the node name is, what's our node name again? So let me just, okay, I think I have it somewhere here. Okay, I'm just going to say oc get nodes. Alright, so I can say oc label node, the name of our node. So environment equals production. So if I do oc get ports again, so you can see that container is being created, and if I do oc get ports, so let me use the -w, which is watch. Container is still creating, so let's wait. Yeah, you can see now that the container is running. So if I do oc get ports, so you can see that the container is now running. And lastly, it is important to know that the cluster administrator can actually configure a node selector label for a project. So like if you're trying to create a new project, so let's say you can say OC ADM new project. So let's say, for example, project, let's just say tech project. So I can just say node selector. I can just say example environment equals development. So this project has been created and the node selector for this project has also been created. So this is usually done if you want to maintain just one node selector label for a particular project and you don't want developers to always create a node selector for their applications. So this is when you can always do this. And even if you have, if you have created a project and you want to, still configure a node selector for an already created project, all you can just need to do is to use the annotate parameter. So I can just say OC annotate TAT. So I can say namespace, which is project, and the project is tech project. Tech project. So tech project, and this is going to be OpenShift.io API. So this is going to be node selector. So I can say node selector equals environment equals development. I can just say overwrite. OC annotate. Okay, I think it should be annotate. Annotate. Alright, so this has been annotated. Thank you for watching, and please don't forget to subscribe to this channel, like, share, comment. When you do this, you encourage us to do more, and I'll see you in the next lesson. Bye for now.